This is prototype 13, Physics 252. We'll be working again with Kirchhoffs laws. Okay, what are they? What are Kirchhoffs laws? You should be able to repeat these verbatim, and they're given by the sum of the potential differences around a closed path is equal to 0, or around a closed circuit. The sum of the currents in any junction is also equal to 0. One of the fundamental items about using Kirchhoffs laws is how do we assign the signs, whether when I trace a circuit element it is positive or it is negative. For a source of EMF, if I trace in the direction from positive to negative, then the sign of the EMF is negative. If I move in a direction from negative to positive, then the sign of the direction is a positive. Once again, you can think of this as if I take a positively charged particle and allow it to move from positive to negative, that is in the direction of the electric field, and it loses energy. If I take a positive charge and move it from minus to positive, then that is opposing the direction of the electric field, and I must do work, and that is to gain energy. So that is a positive. What about a resistor? If I move in the direction along the resistor as the direction of the current is flowing, that both are in the same direction, what is the sign? And that is a negative. If I move in the opposite direction, shown by the red arrow, as the current that is moving uphill, once again, think of it as moving a positive charge against the electric field, the direction of electric field, and that will be a positive. Now let's consider the following circuit. We have that a EMF source, epsilon 1, a resistor R in the left branch, a EMF source 2 and a resistor 2R in the middle branch, and in the right branch we have R and R. We are also given that the EMF 1 is 10 volt, EMF 2 is 6 volt, and R is 10 ohms. Now go ahead and label the current in each branch. Choose the direction you think the current is going to go. I show here where I have chosen the currents and the direction of the currents. On the left branch, I have chosen I1. On the middle branch, I have given it the label I2, and on the right branch, I3. Note that your choices may be different from mine. That's okay. You just follow along, and then if you have labeled it differently, keep it that way and see if you can develop the equations for the way you labeled it. Now let's label the vertices. Okay. So I label vertices A, B, C, D, and E. And what I want you to do is use Kirchhoffs loop law around the loop A, B, C, D, E back to A to get an equation relating I1, I and I2 and EMF1 and EMF2. Also choose the direction that you're going to go around the loop. That does not have to be the same direction as you've chosen the current. Please note that I have corrected it. The statement 3, it should be I1 and I2. Okay, after you've worked out the equation, you should have paused the video, worked out the equation, and started the video. And we now have the positive EMF1 minus I1R minus 2I2R minus EMF2 equals 0, and that we'll call equation 1. Now choose another loop. You don't have to choose the same one I choose. I will choose the loop D, B, C, and back to D, and find another equation relating the currents along that loop and the direction. Now I've chosen the direction. Once again, I'm going clockwise around that loop. Once again, pause the video, write your equation down. And I have the equation EMF2 plus 2I2R minus I3R minus I3R is equal to 0. And that's equation 2. You should understand why EMF is positive, why 2I2R is positive, and why I3R and I3R are negative. Now we need one more equation relating I2, I1, and I3. Why? What does Kirchhoffs' junction law say about the currents at junction B? Pause the video, think about the question, and write down your answer. It simply says that the currents entering the junction are equal to the currents exiting the junction. What goes in comes out. So we can write that in equation form as I1 minus I2 minus I3 must be 0, where in is given the positive sign, out is given the minus sign. So now we have the equation I2 equals I1 plus I3. Now let's work toward the final equations with I1 minus I3 substituting for I2. And I show the final equations below. EMF1 minus EMF2 minus 3I1R plus 2I3R equals 0. And EMF2 plus 2I1R minus 4I3R equals 0. Now it's up to you to solve for I1, I2, and I3. Note that the physics is setting up the equations. Once you get to the equations, from then on, it's mathematics. It's linear equations. So this is the end of the problem.